Right, guys, morning. Yeah, so we're gonna start off where we left off on Friday. Can you all comment your names so I can do this register? Cool. Right, so Karen and Becky and Harry and Billy and Mila and Tristan and Chloe and Louis and Guy and Jake and Jay and George and Danny Elliot, Lucy, and Holly. Right, so missing Scott and Callum. So if you guys are there, please please comment. But let's get started with things. So I set you guys this question as a kind of homework or thing to look at over the weekend. So we're going to go through these. I think these are quite difficult at first for most of you. So yeah, let's get rid of the answers and then let's go through this. Okay, so first one. Find the largest S such that probability x is less than or equal to s is less than 0.1. Alright, what that tells me is that the probability of being less than s is very small. So there's not much chance that you're going to be less than this. So it tells me s must be the left-hand side of our distribution. So if I sketch a little distribution down here, I mean, the most likely value, if I do 20 times 0.4, we're going to get, I think maybe 4, isn't it? 8. So 8 is our most likely outcome. So put 8 there. S is going to be somewhere on that side of the distribution because the probability of being less than s is 0.1. So if I wanted, I could also shade in. So if I make this one s, probability being less than or equal to s. So yeah, s should be shaded as well. So all that probability there is 0.1. And I want to try and find what that value is. So we're going to go, I'm going to put some values into the calculator. So bring up the old calculator. There we go. We're going to go to stats. Let's make that smaller there. So I'm going to fill this in. Again, with the graphical calculator, we need the lowers to all be 0, and then the uppers, let's go from 7 down. So if we do, oh yeah, here we go, 7, 6, 5, 4, 3, 2, 1. So binomial BCD. And just check, so list 1 was the lower, list 2 was the upper. Number of trials is 20. My probability of success was 0.4. list 3 for the answers and execute. There we go. So if you go back to your thing, there's our values. Okay. Alright, so I'm going to copy down a few of these just so you guys can see what's going on. So we've got probability x is less than or equal to, let's go from 6, 5, 4, 3. So less than or equal to 6 was 0.25, so way off. 5 was 0.1255. 4 was 0.0509. And 3 was 0.0159. So, oh wait, sorry, we need to keep going actually. I haven't done enough there. Less than or equal to 2 was 0.00361. Okay, let's just make that one a bit clearer there. So looking at this, we want the biggest S value where the probability is less than 0.1. So here the probability is 0.5, so that's 5%. Here the probability is 0.15, so it's still too big. This is going to be our biggest value where the probability is less than 0.1. So my answer is S equals 2 for this one. Okay, let's try the next one. So I'm using the same distribution. I'm going to find the largest t value such that being less than t is less than 0.3. So again, we're still somewhere in this region, but the probability now is 0.3. So t is probably, I don't know, next one up or somewhere. So I'm going to divide that bar into 2 just so it looks a little bit different. If I get rid of that, let's use blue this time. So I'm going to have my t as that value. Oh, no, I'm not. So I don't want to include t, I want less than t. So if I make t that bar, I shouldn't have shaded that. I'm going to shade all the other ones because we don't want to include it. We want less than t this time. Okay, so let's do it again. We're going to look through our table. Because I've already got the calculator up, we might get away with just reusing these values. When you want to look for 0.3. There we go. So I'm going to copy down 7, 6, and 5. Probability S is less than or equal to 7, 6, 5. So 7 is 0.4158, 6 is 0.25, and 5 is 0.1255. Harry, let me just have sorry, what did I write down? I wrote down 2, didn't I? Why did I do that? Oh, I've done 0.01. Sorry, guys. Yeah, no, you're completely right. That is incorrect. Sorry, guys. I didn't spot that. I did 0.01. I was thinking of percentages there. Yeah, it should equal 4. Do apologise. Well spotted. Okay, yeah, so the next one, so yeah, we're looking for 0.3 this time. So if I look through bit smaller again. Cool. We'll look for the less 0.3. Well, here's 0.25, so 0.3 is going to be in here. But these are less than or equal to's. This is less than. So let's have a quick think. Less than or equal to 7 is the same as less than 8. So I'm going to write that in a different colour. This one here is probability x is less than 8. Next one down, less than or equal to 6 is actually the probability x is less than 7. So this is the one we wanted. We wanted this. So t is going to be 7 for this one here. Okay, on to the next one. So I'm going to clear out some space now. I'll do another sketch because the other one's covered in pen. So, the smallest u, such that the probability of being greater than u is less than 0.05. So that means that u is going to be up there. We're talking about greater than or equal to, so I can shade in the u box and the ones above it. Okay, so a couple ways to do this. Remember, on the class whiz calculator, that can only do less thans. So I'm going to do this on the class whiz. If you are doing it on the graphical, it's slightly easier. So we got 20. I'm going to go from 12, I think. So I'm going to do the probability x is greater than or equal to 12, 13, 14, 15, 16. I reckon that'll be enough, but we'll see. Now, the way we do it, greater than or equal to 12 is the same as 1 minus the probability less than or equal to 11. So I'm going to write that out as well. So greater than or equal to 13, less than or equal to 12. 1 minus. We can copy the pattern, less than or equal to 13. 1 minus less than or equal to 14, 1 minus less than or equal to 15. So I'm going to go back to the calculator. We're going to need to type in some new values this time. So in table, well, let's ignore that for a sec. I'm going to do this on the class whiz calculator instead. So remember, less than or equal to 11, 12, 13, 14. And 15. Actually, where is my class whiz calculator? Oh, there it is. No, I'll leave that there for now. So you can see less than or equal to 11 is 0.9. Oh, I need to do 1 minus these. So remember the trick for doing 1 minus an answer. We've got to make each digit add up to 9 and then the last digit add up to 10. So for this one it's going to be 0.0. 0.05. Gonna run out of space here, aren't I? 6, 6. Okay, so we're almost there with the first one already. Next one, 0.0 2 1 1. So I don't actually need any of the other ones there. I can get rid of those. So we found it was this one here. That is the first one where the probability is less than 0.05, and that gives us greater than 13. So U there is going to be 13. Okay, really quickly, I'll show you how to do this on the graphical calculator as well. So the graphical one, slightly easier. So I'm going to go from, we got 13, we'll go from 12 as our lower, 13 and 14. It's going to delete the other values there. And I need to put the uppers in, so the upper for each one of these, or the most it, oh, I should really delete that one. The most it could be is 20, so each of these needs to have an upper 20 distribution, binomial, BCD, lower list 1, yeah, upper list 2, 20, 0.4, save, calculate, exit, there we go. So the first one of these where the probability is less than 0.05 is this one, so again, U is 13. Okay, last one, find the smallest v such that the probability of greater than v is 0.2. So 0.2, it must be over this side, so if I shade in a few of these. Now we don't want to include v. So v is going to be this bar here that's not shaded. We want stuff to the right of that. So I'll do again one more time, ClassWiz and the graphical. I know this is taking a bit longer, but I just want to make sure all of you can do this on whatever calculator you're on. So on the let's write out the idea first. So if we go, I don't know, let's go 80. Sorry, what's the most likely one? 8. Let's go 9, 10, 11. 9, 10, 11. Yeah. So we want probability x is greater than 9. Probability x is greater than 10. Probability x is greater than 11. Now how we do those on a ClassWiz? Greater than 9 is 1 minus probability x is less than or equal to 9. You can see that from here. We don't want this stuff, so we're going to take away less than or equal to v to get more than v. Okay, so the second one would be 1 minus less than or equal to 10, and then 1 minus less than or equal to 11. So again, ClassWiz. I should put that down there. Okay, so the first one there, remember we've got to do the 1 minus thing again. So we're going to get 0.2447, 0.1276, and 0.0566. Okay, so I want the first one of these to be less than 0.2, which is going to be this one here. So that tells me that v equals 10. And to do that on the graphical, Same kind of idea. But see on the graphical, right, so we want greater than v. So whatever value we find in here, this is going to be greater than or equal to. We need to get one less than it. So if we put in 9, 10, 11, do it, distribution binomial BCD, everything there should be the same as it was before. Execute. There we go, so we want less than 0.2. If I even go to the, let's read, less than 0.2, so greater than, it's going to be this one, greater than or equal to 11. So think about that, this is 11, this one's going to be one less, so V is 10. Right, hopefully that makes a bit more sense now, guys, because I know some of you found that difficult last lecture. Okay, so moving on then. Oh, it's in the other. Give me a sec, it's in the other document. There we go. Right, so I want you guys to try this one. This is basically plan for today is to do some modelling questions based on this topic, and then we're going to look at, we're hopefully going to start the new topic. If we don't start it today, we'll start the new one on Wednesday. But yeah, so if you guys could give this a go. So first of all, write the distribution out. So remember the distribution is the x squiggly line, b, and then the stuff. Yeah, give it a go. So it's 6 marks. I'll give you guys 6 minutes to attempt it, and then we will go through it. So please comment your answers or comment if you need any help. Starting now. Cool. Alright. Can't see any answers from you guys. Do you need some more time, or shall we go through it? What do you reckon? Right, we'll do the first bit because that's easy, but I might give you guys a bit longer. So x, squiggly line, b, n is 10, and p is 0.3. So we also want to describe what x is. So where x is the number of residents that listen to the radio. So you ought to always describe what the variable actually is as well. Okay, find the probability at least half listen to the local radio. So probability at least half means probability x is at least, so greater than or equal to half. So half of 5 is 10. Sorry, half of 10 is 5. So we're trying to find the probability x is greater than or equal to 5. So I'm going to stick to the graphical calculator now. If you guys do need help with the class whiz, please comment and I'll bring it out. But I do want you guys to comment if you need that. Okay, so we're going to go. We don't have to do loads of them this time. It's just a singular question. BCD. So I'm going to change this to variable now. Lower is going to be 5. Upper is going to be 10. Number of trials is 10. And the probability is 0.3. There's no need to save the results. I'm going to go none there. And execute. And the answer 0.1503. That's it. That's all you need to write for your answer there. If you're doing it on the class whiz, you'd probably need to do your x is greater than 5, greater than or equal to 5 is 1 minus probability is less than or equal to 4, and get your answer like that. Okay, and last bit, find the smallest value such that probability x is greater than or equal to s is less than. So let me write that out. Okay, so we're going to sketch it. So the most likely outcome, 0.3 times 10 is 3. So there's 3. There we go. So greater than or equal to s is tiny. So s is going to be up here somewhere. So I'm going to put that one there as s. It's greater than or equal to, so I can shade it. So there's s. And we're trying to find what that value is. So on the graphical calculator, if we go from, I don't know what we're saying, 10. Let's go from, most likely is 3. Let's go 5, 6, 7 maybe. So greater than or equal to 5, 6, 7. So on the graphical, we can just do these. On the class whiz, you need to go 1 minus to 1 lower. Right, so back to our graphical calculator. We're going to go back. Going to put in 5, 6, and 7. Drop the pen. And again, 10 is the highest, so put 10 in. Cool, distribution. Binomial BCD, make it list again. List 1, yep, list 2, yep. Save results, list 3 equals exit, exit. There's our probabilities. So we've got greater than or equal to 5, 0.1502. So it looks like I'm going to need to do one more. So that's what happens if you don't choose perfectly, which is unlikely you're going to always choose perfectly. Okay, so we need to go one more, greater than or equal to 8, just one more. So I'm going to type that one in. So it should always set up the same. It does save it there, so I'm just going to go straight to calculate. So 1.5 times 10 to the minus 3. So that is 0.0015. There we go. Okay, so looking at these, it's going to be 8, because that's the first one where it's less than 0.1. 7 was very close, but the 8 is going to be what s equals 8. That one. Right, has anyone got any questions at all? Please ask if you do, because this is the last lecture we have on this topic. I would like you guys all to be confident with it. So anyone got any questions at all? Right, next one. So if you guys could try this one, I'll give you 5 minutes to do it. Yeah. Please comment your answers as well, because no one's commented in about 10 minutes. So I'm not going to start going through this one until some people have commented, so please get involved. And don't worry about being wrong, that's what learning is. Okay, 5 minutes starting now. All right. Still no comments, guys. So no one's asking for help either. I don't know whether to give you guys more time or start going through it. I'll give you a bit more time, but I don't want to spend ages on this. So if you could please give me some comments, 3 more minutes. We'll see how you get on with that. Right, let's give it a go. So Lucy's commented. Let's see if she's correct. So first of all, let's write the distribution. Always start with this. X is B, N is 50, P is 0.05 there, where X is the number of defective components. So even if the question doesn't ask for it, get in the habit of just writing the distribution every single time. So we want fewer than 2, so we want to find probability X is less than 2 for the first one. So on the class whiz, that will be less than or equal to 1. On the graphical, 1 will be our higher, 0 will be our lower. So let's put the calculator back on. There you go. So distribution, binomial, BCD. Again, we're just doing one value, so variable. Lower is going to be 0. Upper 1. 50 compare. I think this is going to be very unlikely. And 0.05. Save results, don't need to. Okay, so 0.2794. which looks good. Lucy and Guy, good job, you two. Right, next one, more than 5. The probability x is greater than 5. So remember, class ways, you're going to need to do 1 minus less than or equal to 1 minus the probability x is less than or equal to 4. So I'm going to write that down anyway. On the graphical calculator, however, we're going to go greater than or equal to 6. So lower is going to be 6. Upper is going to be 50. Everything else is the same. There we go. So 0.0378. Good. So again, well done, you two. And last bit, they'll stop if defectives reach greater than a certain value d. So I'm going to draw my distribution. Most likely, so 0.05 times 50, which is most likely is 2.5. Interesting. So 1. Oh. I'm not going to draw 50. It looks something like that. We want to find what d is, so it's greater than this value. So d will be the next one there. And we want to know all this probability here, 0.05. Okay. So it's probably going to be, I'm going to go with, you guys are going for 5. So if you go to list up here, put everything in. Okay, so I'm going to go back to my list and delete everything. Now you guys are going for 5. I'm going to go from 4 then. So we're going to go greater than or equal to, well, let's go greater than or equal to 3, greater than or equal to 4, 5, 6, 7. And we know 50 is our top value. Oops. Alright, and we're going to go distribution, binomial, BCD. Yep, everything's there. Save results list 3. And let's do it. And if we go back, there we go. So I'm just going to write all these down again. So I want greater than 5. Okay, so greater than or equal to 3, 4, 5. Wait, no, we don't. That's not rubbish. 3, 4, 5, 6, 7, 8. You don't have to write all these down. I'm just doing so I can show you guys what's going on. So if you did this on the class whiz calculator, you want to do 1 minus less than or equal to the one lower than it, and write all of those down. Sorry, Scott. Yeah, go back to the beginning. I'll mark you down on the register. So greater than or equal to 3 is 0.4594, 0.2395, 0.1036, 0.0377. Keep going down. No 0.0117. So get rid of that last one. Okay, remember we're talking about greater than. So greater than or equal to 3 is going to be greater than 4. Sorry, no, it's not. Greater than or equal to 3 is going to be greater than 2. Greater than or equal to 4 is greater than 3. Greater than 4. We can go through all of these. Greater than 6. So that's what we've actually found out with these. So don't forget what the actual point is, if you like. We wanted it to be less than 5%. So there's the 5% level. That's going to be my 1. So it's D is going to be 5. Well done, you two. They got that. Cool, brilliant. Okay, so let me fill Scott in the register, and then we'll move on. I've closed the register. Okay. Right. Anyway, next one. Oh, okay, cool. We're done. Nice. Good timing. Wait a minute. That's very weird. Okay. Anyway, I just did a quick recap on this slide. Just so you guys can kind of copy down, I did one more kind of set of examples for when to use the calculator and when not to use the calculator. Oh, sorry, how to use it on graphical and how to use it on ClassWiz. So if you guys want to copy that down and take a picture of it, this is how you do things on graphical. Over there's how you do things on the ClassWiz. So the point there in black is to remember it's less than or equal to or more than or equal to. So in order to do less than or greater or more than, these are the methods for doing it. So on the ClassWiz, the only one on the ClassWiz that you can just do is when it's less than or equal to. You just type that in, done. If it's less than, you need to go less than or equal to the one lower. If you want to do more than, you need to do 1 minus. And then if it's just more than, it's going to be the same number. If it's more than or equal to, it's going to be 1 lower than the value 1's in. If you do a sketch, these are a lot easier to see. For the graphical calculator, this will do less than or equal to or more than or equal to, but you need to put in the upper and lower boundaries. So less than 5 is going to be less than or equal to 4. More than 5 is going to be more than or equal to 6. So be careful with those. I think the graphical is slightly easier, but you do have to type in a bit more. And remember to show these workings. Even if you're doing it all on the graphical calculator, it's still useful to show these workings because that's where your method marks are going to be coming from. Okay, moving on. So, what have we got? Yeah, I think we'll just spend today on the old stuff and we'll move on to the new topic on Wednesday. So I might change the title of this lecture because it's not going to have any hypothesis tests. So anyway, could you guys try this one? I think I'll give you 5 minutes to do this one. Yeah, so we're a lecture behind, but it's because we missed that Friday due to VE Day. Right, so 5 minutes starting from now, and make sure you comment, please, guys, if you need help or if you got your answers. So starting now. Right. So, yeah, looks pretty good. You two have the same answers. That's hopeful. Right. So, X is B. There's 15 plants, and probability of being blue is 0.25, where X is the number of blue plants. So first we want probability X equals 4. So on the calculator, this is going to be a binomial PD, so percentage distribution. So this is where we just type in the value. So distribution binomial BPD. Variable for our data, X equals 4. Linear distribution, we've got 15 trials. And probability of success is 0.25. Save res, we don't need to do that. There you go. So we get 0.2252. Nice. Good. So all of you got that. Lucy, Karen, try and go to 4 decimal places is the standard for these. Okay, at most 3. At most means less than or equal to 3 because we're allowed to have 3 included. So we do need a percentage distribution this time. So we go back, distribution, binomial BCD. So at most 3. So low is going to be 0, most is going to be 3. Everything else should stay the same. Oops. And we get 0.4612. 0.13 even with correct rounding. So Elliot, your rounding is wrong. And the other two, 4 decimal places if you could. Right, and the last one, between 3 and 6 inclusive. So between 3 and 6. So on the graphical calculator, this is really easy. You just type in 6 and 3 and push equals. I'll show you quickly on the class whiz, so with a quick sketch. So we want 3, 4, 5, 6. We want all this stuff. So we don't want any of this stuff. So we're going to do x is less than or equal to 6. Take away probability x is less than or equal to 2. And that's how you do it on the class whiz calculator. Either way you do it, if I type it in on the other one, it's going from 3. So 3 is our lower. 6 is our upper. Done. So 0.7073. So again, yeah, all of you good, but you need to include that last decimal place if you could there. Right, we're getting close to the end. Right, we're going to try the hardest one because there is a hard question here. So it's an 8-minute question. I'll give you guys 8 minutes to do it, and then we're going to have to hastily work our way through it. I really want to get this one done though because it does. Part A and B are fine. Part C gets difficult. My hint for part C: use the manual expansion. So what I mean by that is use the NCR p to the n 1 minus p to the n minus r. The thing we did in the first lecture where we did it manually without the calculator, you need to use for part C. Alright, so 8 minutes starting now. Comment if you need help as well, because this one is quite challenging. Cool. Right. Okay. No one's answered anything, but we've got to get through this, or we're going to run out of time. So. State the conditions under which it is appropriate to assume a random variable has a binomial. It says 4 conditions, 2 outcomes. Outcomes independent, fixed probability of success, and a fixed number of trials. There you go. So those are your 4 conditions where you can use binomial. Okay, so a door-to-door canvasser tries to persuade people to get double glazing. So the probability that his canvassing is 0.05. And we're told here the first 10 houses. So X is B, 10 houses, 0.05, where X is the number of houses he sells to. So we want to find the probability. You'll have at least 2, so probability X is greater than or equal to 2. So calculator up. Lower is going to be 2. Upper is going to be 10 because there's 10 houses. Number of trials is 10 as well. And P is 0.05. Okay, so we get 0.08614 861 in that case. Okay. Now it gets difficult. So C. Calculate the smallest number of houses he must canvass. So the probability of his getting at least 1 exceeds 0.99. There's a lot there to kind of break down. So in other words, we now have X, B, we don't know what N is. The probability of success is still the same, but we don't know what N is. I'm just going to clear everything, I think, because this might require some space. So, we don't know what N is. This is what we're trying to find out. We're trying to find N in this case, which is why it's difficult and why we have to do things a bit weirdly. And we want the probability of at least 1 greater than or equal to 1 to exceed 0.99. So we're trying to use all of this to try and find N. Okay, so we can draw it. Don't know how much up it will be, but 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you go on and on and on. We want greater than or equal to 1, so we want all of this area here is 0.99. And we want to try and find what N is, basically. Okay, so what we can do, instead of saying greater than or equal to 1, because that's going to be impossible, we can say less than or equal to 1 is 1 minus that. So greater than or equal to 1 is the same as 1 minus the probability X is less than or equal to 0. So we're going to use that instead. 1 minus probability X is less than or equal to 0, which is the same thing as less than or equal to 1. You can't be less than 0, so I'm going to change that to say X equals 0. So 1 minus the probability X equals 0 needs to exceed 0.99. And I can rearrange that to get the probability X equals 0 has to be less than 0.01. So can everyone see what we've done there? We started off with what they said. X greater than or equal to 1 needs to be more than 0.99, which is this sentence here. I then said, well, we can't do that. That's going to give us lots of values. Let's flip it around. Let's say that is the same as 1 minus the probability x is 0. So the red bit is the same as 1 minus the white bit. So that's where we get to this. And that probability, which is this, should be greater than 0.99. So it should be greater than 0.99. So I then added this bit to this side, took 0.99 from this side, which gave me that expression there. Okay, now to do that, we're going to do it as I gave you in the hint. We're going to do it kind of manually. So we're going to say if I okay. All right, so we need 0. Probability of success is 0.05. So we want 0.05 to happen 0 times, because we're winning, well, he's tallying 0 times. And then we're going to get 0.95 to happen n times. Yep. And we're going to get nc0. So that there is my probability. Probability x is 0 is this. Winning, or success 0 times, failure n times, if you don't know, we want to try and find this n, we're going to have nc0. Now, what is nc0? Could you guys all comment what nc0 is, please, just while I clear some of the screen? nc0, we don't know what n is, but what is nc0? What's anything c0? One, good. All right, so we get 1 times 0.05 to the 0. Anything to the 0 is also 1, times by 0.95 to the n. So you get 1 times 1 times 0.95 to the n. So my probability x is 0 is 0.95 to the n. So you can take it over here and say 0.95 to the n is less than 0.01. Now, how do we solve an equation like this? Any ideas? Logs. Well done, Billy. Cool. So I'm going to log both sides. Going to use the power rule. Got to be careful now. I want to divide by log 0.95. Remember, if I divide by a negative, I need to swap the sign around. Is log of 0.95 positive or is it negative? Have a think. So I'm going to divide by it, but do I need to swap the sign of my inequality? And you can do it with a sketch if you like. You can do a quick sketch of log. So log crosses at 1. So is log of 0.95 positive or negative? Wait for you guys to respond. Is log of 0.95 negative? Type it into calculator if you want, but it's best to just know this and be able to spot it, especially from that sketch. Negative, yeah, good. So because I'm dividing by a negative, I need to swap the sign around. So we're going to get x is greater than log 0.01 divided by log 0.95. I can type that into my calculator, so I'm going to use this one. Log 0.01 divided by log 0.95. And I get x is greater than 89. Or why have I gone to x suddenly? It should be an n, shouldn't it? N is greater than 89.78. So what's the smallest number of houses he has to canvass? It's going to be 90 houses. So we've worked out if this door-to-door salesman goes to 90 houses, they are likely, very likely, to get at least one sale. Cool. All right. Those questions are quite difficult. Might give you guys one to do really quickly. So if I clear this screen and I'll make one up. So the probability Alex's band sell a vinyl record at a gig is 0.125. Oh, let's make it less likely. Note point 0.85. How many gigs does the band need to play for the probability of selling at least one vinyl to exceed 0.99. So, semi-realistic question there. Yeah, so you've got band trying to sell vinyl records. They probability sell vinyl records 0.085. How many gigs does the band need to play for the probability of selling at least one vinyl record to exceed 0.99? So it's basically the same question with different numbers. See if you guys can do it without looking at your notes. See if you can do it just from what you heard in the lecture just now. If you can't, go back through the video, watch it, copy it, make some notes for each step. So yeah, you got 4 minutes to do that now. We'll go through this as a starter on Wednesday. So A1. And then we'll start the new topic after that. So there you go, guys. If you want to start that now, when it comes back, because it's just disappeared. Yeah, that's going to be it for today. So I'll stick around for 4 minutes while you guys try this in case you do need any hints or help. But hopefully it will appear. Okay, yeah, cool. It should load any sec now. There you go, cool. So you got 3 more minutes of the lecture now. Give it a go. If you need any help, comment. And otherwise, I'll see you guys on Wednesday. Cheers, guys. I will see you on Wednesday.